Hi, welcome back to Chemistry Laboratory, University of KABRIDAHAR, Somali region, Ethiopia. This is Dr. Rajshekhar Medidi. Today we'll discuss about the very important experiment, that is mixture analysis. If we see the systematic procedure of this experiment, we can see the aim, that is to determine the percentage composition of the mixture sodium chloride and sodium hydroxide in a given sample. The apparatus required for this experimentation will be consisting of the burette, pipette, and the volumetric flask, and the small beakers, magnetic stirrer, wash bottle, measuring cylinder, etc. This is about the apparatus. And coming to the chemicals required, the sodium chloride, sodium hydroxide, hydrochloric acid are the chemicals. Coming to the indicator, the indicator used in this experiment is phenolphthalein indicator we can use. So the end point will be the pink color to colorless. All the procedure for the volumetric analysis consisting of two different parts. Part 1 will be the standardization process and part 2 will be the estimation process. Coming to the procedure part 1, that is the standardization of hydrochloric acid by using standard solution of sodium carbonate. Here in this procedure, sodium carbonate is the known strength, that is the primary standard of taken 0.05 normal. From that known strength of sodium carbonate, we have to estimate the unknown strength of hydrochloric acid. From this part 1, we will get the strength of hydrochloric acid. So this is the hydrochloric acid, which is already standardized by using the standard solution of sodium carbonate, and the strength is already identified. And now this is the mixture, that is sodium chloride and sodium hydroxide mixture is there. Now if you see these two reagents, these two are colorless solutions. So now we have to identify which solution is acid and which solution is the mixture solution. So the bigger one, the bigger reagent bottle is already regarded as the acid solution of known concentration hydrochloric acid, and this smaller reagent is the mixture containing sodium chloride and sodium hydroxide. So in this procedure, in this experiment, we will find out the amount of sodium chloride and amount of sodium hydroxide present in this mixture, and also finding out the percentage composition in this mixture. That is the experiment. Now, by using the known strength of hydrochloric acid, we will find out the amount of grams of sodium chloride and sodium hydroxide from this. Now we have come into the experimentation spot. This is the workbench. This is called as the magnetic stirrer. We will use it for the stirring the solution. And this is the reagent bottle containing hydrochloric acid of known strength. And this is the mixture containing sodium chloride and sodium hydroxide solution called as a mixture. And this is the indicator called as phenolphthalein, which is used to identify the color change. So this is the beaker. Now I will take the mixture into the small beaker. Now this is the pipette, already washed. I will take 10 ml of the mixture. So this is the 10 ml capacity, right? I have taken 10 ml of the mixture containing sodium chloride and sodium hydroxide. Now I am adding 30 ml of distilled water as per the procedure. Yes. Now the solution is colorless. Now I am making it on the stirrer, magnetic stirrer. Yeah. Now this is the phenolphthalein indicator. 1 drop is to be added, or 2 drops is added. Yes. You can see the color, dark pink color is formed. So this is the mixture, sodium chloride, sodium hydroxide plus water. All the three are colorless in solution. When we add the phenolphthalein indicator, which is also colorless, this is also colorless actually. When we add this phenolphthalein indicator, it turns into brilliant pink color. So the reason behind this is phenolphthalein in presence of basic medium exhibits the color pink color. That is why the solution is pink in color. Now we will titrate with the acid and we'll see how the color changes and when the reaction ends. Right? So now I will take the acid into this burette. This is the acid of known strength. Yes. So this is exactly up to the mark as it is filled. Now I have tied it with the solution mixture containing the phenolphthalein. So now this is the standard strength of hydrochloric acid. This is already standardized by means of sodium carbonate, I told you before in part 1. So now the strength of this hydrochloric acid is 0.0434. So from this we'll find out the amount of sodium chloride, sodium hydroxide present inside the mixture, right? Now I will start the reaction. Let us see how the color changes when the reaction ends. Slowly I am adding the hydrochloric acid from the burette. Now if you observe the reaction slowly, hydrochloric acid is coming slowly drop by drop and reacting with the mixture solution containing phenolphthalein. And slowly what happens is the sodium hydroxide present inside the mixture slowly converts into sodium chloride. So when it is completely converts into sodium chloride, and then the mixture becomes neutral. After that, if you add excess amount of 1 drop of HCl from the burette, immediately the color of the phenolphthalein changes to colorless solution. That will be the end of the reaction. Now let us see when the color changes. Slowly we have to add the hydrochloric acid so that the reaction will be fruitful. You can observe the color. Still sodium hydroxide is there in the beaker. Slowly it will convert into sodium chloride. Yes, suddenly the color changes. See, the color changes to pink color to colorless. So you can see the change of color. Now the burette reading is exactly 14 ml. You can see the color. Pink color change to colorless. So this ends the reaction. Now we can stop the stirrer. The value is recorded as 14 ml. Now we can find out the strength of this mixture containing the composition also we can find out. Now if you see the mechanism here, so what happens is the sodium hydroxide present inside the flask when react with hydrochloric acid, sodium hydroxide converts into sodium chloride. Already sodium chloride is there in the mixture, and now the sodium hydroxide completely converts into sodium chloride, and now the solution is nothing but completely neutral solution. So the color change, why the color change from pink to colorless means we can understand here. Phenolphthalein indicator exhibits pink color in the basic medium because sodium hydroxide is a base, it exhibits the pink color. So when the titration is going on, what happens is sodium hydroxide converts into sodium chloride and finally the reaction becomes neutralized. So when you add excess amount of 1 drop from the burette after the reaction is completed, the drop at 14 ml exactly, what happens is the mixture converts into acidic in nature. Phenolphthalein exhibits colorless in acidic medium. That is why when excess amount of drop of hydrochloric acid is flask, immediately it converts into the colorless solution. Now this beaker solution is slightly acidic in nature. That's why the phenolphthalein changes its color from pink to colorless. So this is the point at which the color changed from pink to colorless. That point is called as the end point or the equivalence point. So this is about the analysis part, the experimentation part. Now we'll do the calculation. Determination of mixture analysis, sodium chloride and sodium hydroxide. Aim is to determine the mixture sodium chloride and sodium hydroxide from the flask with hydrochloric acid. Apparatus required is pipette, burette, beakers, measuring jar, magnetic stirrer, wash bottle. And coming to the chemicals required, sodium chloride, sodium hydroxide, hydrochloric acid. And indicator, use this phenolphthalein indicator. And endpoint is pink color in the basic medium changes to colorless in the acidic medium. Coming to the procedure. Procedure is, before procedure the reaction here is sodium hydroxide reacts with hydrochloric acid to form sodium chloride salt and water. Procedure. 10 ml of mixture is taken plus 30 ml of distilled water is added. Then phenolphthalein indicator is added. It forms pink color. Then titration takes place with the HCl from the burette, which is having the strength of 0.0434 normal, which is already found from the part 1 with the standard sodium carbonate solution. So with the standard strength of hydrochloric acid, we are determining the mixture concentration. Now, in the procedure, and when the reaction is going on, titration is going on, pink color changes to colorless. Endpoint is colorless solution, and the value is recorded. Let us see the tabular form here. You can see the table. Table contains the serial number, volume of mixture, burette readings, initial, final, and volume of HCl consumed. So here we have to do three titrations, and students have done other two titrations, and I have done one titration. Let us incorporate all the three values. The first titration done by me, we got the serial number 1, volume of mixture is 10 ml taken, burette readings is initial value 0.00 ml, and final volume is 14 ml, and the volume of HCl will be the 14 ml. And because three titrations have been done, 2 times the 14 value is repeated, so 14 ml is confirmed as a final volume. So now, as per the formula, law of equivalence, N1V1 is equals to N2V2, where N1 can be regarded as N1V1 can be regarded as the mixture, and N2V2 for the hydrochloric acid. Now N1 is equals to normality of mixture containing sodium hydroxide, because it reacts first, that will be unknown, we have to find out. And V1 is equals to volume of mixture taken, that is 10 ml. N2 is equals to normality of HCl, that is 0.0434, which is already find out from the previous part 1. And V2 is equals to volume of HCl, that is 14 ml, that is consumed. Now let us, yes, from this formula we have to find out N1, that is normality of mixture containing sodium hydroxide. So N1 is equals to N2V2 by V1, that is N2 is equals to 0.0434, and V2 is equals to 14 ml that we got from the titer value, and V1 is equals to 10 ml mixture taken. So we got the normality of sodium hydroxide in the mixture as it reacts first will be 0.06076 normal. This is about the strength of the mixture containing sodium hydroxide alone. Now from this, amount of sodium hydroxide present in the mixture can be calculated by the formula normality of sodium hydroxide obtained into equivalent weight of sodium hydroxide, that is 40. So now the normality and equivalent weight of sodium hydroxide can be calculated, that is 0.06076 into 40 is equals to 2.4304 grams. This is about the weight or the grams of sodium hydroxide present in the mixture, that is 2.4304. Now coming to the amount of the sodium chloride present, since the total amount of mixture taken is 5 grams, so the grams of sodium hydroxide obtained is 2.4304. So 5 minus 2.4304 is equals to 2.5696. That will be automatically the weight of sodium chloride. So total weight will be 5 grams. Now percentage calculation. Percentage of sodium hydroxide present in the mixture is equals to 2.4304 by 5 into 100. That is divided by 5 means total grams taken. So the amount of the percentage composition of sodium hydroxide is 48.608%. And the percentage composition of sodium chloride present in the mixture is 2.5696 by 5 into 100. That is 51.392%. Total will be 100%. Now from this experiment we have been determined the amount of sodium hydroxide present inside the mixture and also the amount of sodium chloride present in the mixture. We have also calculated the percentage composition of sodium hydroxide and sodium chloride. We will see the other two titrations that is carried out by the students, because we have to take the 3 consecutive titrations. The value should be the same. So let us perform the other 2 titrations with the students and let us find out the value, that is 14 ml, that is accurate. Let us see the performance of the students from KABRIDAHAR University Chemistry Department. Neutralizes, the pink color changes to colorless. Slowly you can see the color change. Pink color is converting into colorless. Still the reaction is going on. Sodium hydroxide is there in the beaker. Now if you add slowly the hydrochloric acid, you can observe the color change. All of you observe the color change? Yes. See, stop the reaction. So pink color change to colorless. That is end of the reaction. Determination of mixture composition. Yes. All of you again observe the color change reaction. Now Mishara is doing now. From the burette HCl is pouring slowly, drop by drop. The flask contains sodium chloride, sodium hydroxide. Now sodium hydroxide reacts to form sodium chloride, and now the pink color changes to colorless. That is the end point. Observe the color change. Pink color changes to colorless. Slowly, slowly, slowly. Yes, see the color change. That is the end point.